Why one-tailed p-values are rarely appropriate. In this video, I'll explain why one's choice of a one-tailed or two-tailed p-value matters, and then I'll talk about different ways that you can make the choice of whether you should use a one-tailed or two-tailed value. The first approach is very common, called the directional hypothesis approach, and I'm going to argue that it's not a good approach and we should abandon it. Then I'll describe what might be called a what would I do approach, and I'll argue that that's better. And throughout the video, I'll try and explain why a one-tailed p-value is rarely appropriate in most research situations. In a previous video, I described how to interpret p-values. Generally speaking, a smaller p-value is stronger evidence against the null hypothesis. Common guidelines are a p-value that is close to 0.2 or higher is considered to be consistent with the null hypothesis. A p-value close to 0.1 is considered weak evidence against the null hypothesis. P-values close to 0.05 are considered moderate evidence against the null, and p-values of 0.01 are considered strong evidence against the null hypothesis. Researchers must choose whether they plan to use a one-tailed or two-tailed p-value before they conduct their research. You can see in this example that if I ran a study and got a t-value of 1.65 and I was doing a two-tailed test, the p-value would be weak evidence against the null hypothesis, a p equal to 0.1. However, the same data would yield moderate evidence against the null if I had planned to do a one-tailed test. A researcher's choice of whether they should use a one- or two-tailed p-value is actually linked to the null hypothesis that they're testing in their study. And of course, the null hypothesis is set up before they actually collect their data. It might be tempting to always use one-tailed p-values because they're always going to be smaller than two-tailed p-values, thereby providing stronger evidence against the null. But that's really not appropriate because one-tailed p-values and two-tailed p-values don't mean the same thing. And I'll explain that on the next slide. Imagine a situation in which a researcher is trying to test if a drug has an effect on memory. Further, imagine that the researcher chooses to test a two-tailed null hypothesis, specifically that this drug does not affect memory at all. The p-value that the researcher has chosen is really looking to find evidence in two different tails, or three different categories. The result can find evidence that the drug increases memory. It can find evidence that the drug decreases memory, or it can find that there's not sufficient evidence to say that it has any effect on memory. This type of setup is looking for three different categories of possible outcomes. However, in a one-tailed null hypothesis experiment, specifically testing the hypothesis that the drug does not increase memory, the p-value is set up to find really evidence in just one tail. It's trying to find if there's sufficient evidence to conclude that the drug increases memory scores. And so there's just two categories, and the other category is there's just insufficient evidence to say that the drug increases memory. These two setups are not interchangeable. You have to pick which one of these you are testing for when you design your study. Changing it after the fact is inappropriate. They're not interchangeable. A very common approach to making the choice between one- and two-tailed p-values is the directional hypothesis approach. If a researcher expects the treatment will cause an increase in a certain dependent variable, then they would say a one-tailed test is justified. For example, if a researcher expects a drug will increase memory scores, they might plan to use a one-tailed test. In this type of situation, the null hypothesis that they're actually planning to test is that the drug will not increase scores. If the researcher is testing that one-tailed null hypothesis that drug scores do not increase memory, and they, for some unexpected reason, find that the drug actually decreases memory, and they get a result that indicates the p-value is 0.99, they would have very compelling evidence that the data are consistent with the null. It is very compelling that the drug does not increase memory. However, if they had planned their study to be a two-tailed test, their conclusion would be very different. If they had been testing the two-tailed null hypothesis, that the drug does not affect memory scores, it doesn't change it, increasing it or decreasing it, the same outcome would have a p-value of 0.01, which would be strong evidence against the null. Of course, it's a different null hypothesis. Here they would have evidence to say that they have strong evidence that the drug actually decreases memory. If the original null hypothesis was one-tailed, that the drug does not increase memory, it is not appropriate for a researcher to then use a p-value of 0.99 to argue that the drug actually decreases memory. You're limited to the null hypothesis that you started with. If you're going to use a one-tailed test honestly, you can't use a null result, like a p equals 0.99, to report an important finding in the non-predicted direction. If you do, you changed your null hypothesis after you saw the data, and that's not appropriate. You should only plan to use a one-tailed p-value when you're willing to report an unexpected opposite result as a null result. And I'll argue in the rest of this video that that is rarely the case. An alternative approach that's better than the directional hypothesis approach is to use the what would I do approach. In this approach, a researcher simply asks themselves before they collect their data, what would I do if I got an unexpected result in the opposite direction? If they would report that result or research that result or really be interested in that result in any way, they should really be using a two-tailed p-value. If, on the other hand, they would consider that opposite result to be uninteresting, just like a perhaps null result, then a one-tailed p-value would be justified. Returning to our previous example, if a drug unexpectedly decreased memory, a researcher would have the ability to report that as strong evidence against the null hypothesis that the drug has no effect on memory. They could then conclude and report that the drug decreased memory in their study. Here I'll try and highlight when a one-tailed p-value and when a two-tailed p-value would be deemed appropriate within the what would I do approach. The first thing you need to do is identify the potential outcomes for your research. The three possible outcomes in this case are a treatment can increase a dependent variable, and in this case, that's what the researcher is predicting. The treatment might have no effect on the dependent variable, or the treatment might, for some unknown reason, decrease the dependent variable, the opposite outcome. A one-tailed p-value is only going to be appropriate if the null result and the opposite result would lead to the same behavior on the part of the researcher. In this case, if you found that the treatment had no effect, or the treatment actually decreased the dependent variable, if your behavior would be the same in both of those situations, then a one-tailed p-value would be appropriate. This is probably rarely the case if researchers are honest with themselves. Instead, a two-tailed p-value is going to be more appropriate in most research situations. If a result came out the opposite of a prediction, for example, if a treatment decreased the dependent variable when it was expected to increase it, most researchers are going to want to understand why. They're going to want to research the mechanisms that cause that change. They're going to want to report that result. If that's the case, they should have designed their study to be a two-tailed test from the very beginning. Changing it after the fact is inappropriate. This behavior of researching the opposite effect is very different behavior than they would have exhibited if they got a null result. And since those two outcomes would lead to different behavior on the researcher's part, a two-tailed p-value is most appropriate. Before we conclude, I want to make it clear why you can't just pick the p-value you want after you see your results. The p-value is supposed to be an objective index of the evidence against the null hypothesis, with smaller p-values indicating stronger evidence against the null hypothesis. The p-value is not an objective measure if you change the research question, in other words, if you change the null hypothesis after you see the results. If you start with a one-tailed p-value, you should end with a one-tailed p-value. Here are some readings explaining in more depth why one-tailed p-values are really inappropriate in most research situations. If you're interested in learning more about statistics, visit us at learnstats.com.